So there's other videos that I've posted on the rest of this practice test, or the study guide for the big test, but I did not make a video on these four right here on the back side. It says there'll be 3 to 4 questions on factoring perfect square, binomials, and trinomials. So if you have a perfect square term in the front and in the back, you might be able to square root it and put it in your factored format. However, right here, even though you have a perfect square term here and a perfect square term back here, you cannot plug it into this format. Why? Because, well, first of all, let's pretend, let's try to do it. The square root of 81, x squared, that's 9x, and the square root of 25 is 5. So you have a 9x and a 5. Now, when you're trying to determine what symbols belong in here, it has to be a plus and a minus in order for the middle terms to cancel out, because there is no middle term. But if you did have a plus here and a minus there, at the very end, when you distribute, a positive 5 times a negative 5 is a negative 25, not a positive 25. And it can't be both negatives, because then you'd have a middle term that's negative. And it can't be both positives, because you'd have a middle term that's positive, and there is no middle term. So right here, it's not factorable. Okay. If we remember the title specifically of section 8.8, section 8.8, the title was Difference of Two Squares. Now, this is obviously not a difference of two squares. This is adding two squares. So you cannot use the shortcut here. It's just simply not factorable, right? You cannot factor it. So this one right here is prime. That's the word we're going to be using on the test, prime. What does that mean? That means not factorable. Again, the shortcut only works if you have a difference of two squares. If you had a minus sign between these two perfect square terms, then yeah, you could put a 9x, a 5, a 9x, a 5, 1 plus, 1 minus, and that would give you the minus of the 25, but there would be no middle term. But right here, because it's a plus, that messes everything up. I mean, if you did just guess at it, I mean, not guess at it, if you did the square root, got the 9x, did the square root, got the 5, if you started double checking your answer, 9x times 9x, that's 81x squared. 9x times negative 5, that's 45x, that's negative 45x. And positive 5x times 9, that's a positive 45x, so the middle terms would cancel. But then when you go positive 5 times negative 5, you get a negative 25, not a positive 25. So you know it would not work. So nope, it is prime, which means not factorable. Let's try this one over here. Will this one work? Heck yes, right here you really do have a difference of two squares. So if you square root that one and you square root this one, you will be able to plug it into your answer format. The square root of 81x squared, that's 9x. The square root of 25 is 5. So you have a 9x and a 5 on both binomials. And of course, one will be positive and one will be negative. Okay? Because a positive 5 and a negative 5 will give you the negative 25. And the opposite signs, when you distribute and combine like terms, the middle term will cancel out, right? So let's put a plus and a minus, or a minus and a plus. It doesn't really matter. But as you can see, it will work. 9x times 9x is 81x squared. 9x times negative 5 is negative 45x. Positive 5 times positive 9x is a positive 45x. These guys cancel out, and the 5 times negative 5 is negative 25. So you really do get 81x squared minus 25. All you have to do is understand that there's a difference of two squares, then you could factor it and you'll be done. You don't even have to check it, really. Let's move on to the next one here. So this one's not a difference of two squares. It might be a perfect square quadratic trinomial. So perfect square term here, perfect square term back here. Let's put our factored format. Let's take the square root of 25x squared. That's 5x. And you write it on both first parts of the binomial. And 2 and 2, because the square root of 4 is 2. Both symbols have to be negative, right? So we're going to put a negative there and a negative there. And that's about it. That's the factored form. The only other way to write it is like this. 5x minus 2 squared. So this is acceptable. On the test, you will see it written like that as a binomial squared.
Is it going to be multiple choice?
Half of it is multiple choice. The other half is open response. Okay. And there's a video already uploaded to Edmodo giving you an example of what type of multiple choice. Because it's not just A, B, C, D. It's going to be A, B, C, D, E. Yes?
The only reason why the number 2 worked for having a negative and a positive answer was because there was no middle term, right?
Yes, exactly. On this one, the only reason why the plus and the minus worked is because there was no middle term. The middle terms eliminate. That's why it's a binomial. This one's a difference of 2 squares. This is a perfect square quadratic trinomial. Of course, when you have a perfect square quadratic trinomial, you should double check it, right? Let's just double check it just for fun here. When I say 5x times 5x, I'll get 25x squared. And so far, so good. Up there, we have a 25x squared. But then when I go 5x times negative 2, I'll get a negative 10x. And then a negative 2 times another 5x is another negative 10x. And of course, those middle terms really do become negative 20x when you combine them. And that's what we have up here, negative 20x. And of course, at the very end, negative 2 times negative 2, that is positive 4. And that's a positive 4 up there. So we've verified, we've double checked. I don't want this as a part of your answer. This is your answer right here, the factored form format. But I just verified, I double checked, I made sure that I have the right answer. Let's look at this last one. Is this a perfect square term? No. Is this one? No. So I can't do square roots. GCF, absolutely. The very first type of factoring is pulling out the GCF. That's the very first type of factoring you should always try. Now somebody might be thinking, I want to multiply A times C. No way. 18 times 98, you're going to get a huge number. Forget that. So let's just pull out the GCF. What is the GCF in this case? Give me a guess if you don't know. 9?
No, never mind. No.
9's not going to work.
6.
6? Possibly. 6 might work. I'm not sure. Like if we have a calculator, is 84 divisible? Doesn't work with 98. Okay, so 6 didn't work. Okay. 8 times what is 84? That won't work. So I would go with at least 2. 2, because they're all even numbers, right? So let's go with 2 at least. Now, if we divide everything by 2, we're going to end up with a 9x squared, a 42x, and a 49. Now, if you look at the inside, you actually have a perfect square quadratic trinomial. I mean, it looks like we have a perfect square quadratic trinomial. So let's set up the factored form, and let's take the square root of 9x squared. That'll be a 3x. Put it on both first parts of the binomial. And the square root of 49 is 7, so you put the 7 as the second part of both binomials. Now how about those signs? Plus and plus. Now let's just verify. I'm not even going to show my work. I'm just going to do it in my head. 3x times 3x, 9x squared. So far, so good. 3x times 7, 21x. 7 times 3x is another 21x. So if you added both 21x with 21x, you really will get the 42x. So it does work. I don't need to show my work, but you should double check it. Bring down that 2, and all they're asking for is the factor. You are done. Now, if this would have been equal to 0, then you'd have to divide by 2 and then split each of these and set them each equal to 0 and solve, right? But anyway, that's the only part I did not have recorded. Everything else is recorded. So please make sure you watch the other videos that are uploaded onto Edmodo. They're not recent on my YouTube channel. You have to actually get on Edmodo and watch the videos that I posted for the other questions here.